Good afternoon, everybody. My name is Jean-Claude Borrell from TNO Diana BV. I'm going to hold this webinar today. Thank you for attending this webinar. I invite you to raise any questions at the end of the presentation using the question pane that you can find on your right, or by simply dropping an email to info@tnodiana.com. Today I'm going to highlight the new workflow of a freshly released Diana 10, which is now available for about a week. And probably you have all been informed by email that our product was available. So this is our new graphical user interface. That's actually the major development of our Diana 10 version. Now you can do everything: pre-processing, analysis, and post-processing in one window, which is a major step, especially for people who have been using previous version of Diana. In order to highlight the Diana 10 capability and workflow, I'm going to model a 4-point bending test today, a 2D model. And I will show you how to set up the model, how to set up the analysis, and what kind of output can be presented from our new GUI. So to start with, I start a new project. So this is the starting point of any new model that you will build or create in Diana 10. You can give it a name. I call it 4 points bending. You can choose in which folder you want this to be placed. I've created a special folder for this demo today. You can also check, and this will be used as a default location. This will be a structural analysis. It will be a two-dimensional case. Here you can define a model size, which is basically the outer dimension of the modeling box. For our case, I choose 100 meter. You can already define the mesh order. I choose quadratic, and also the measure type, quad dominant or tetradominant. In that case, I choose for quad dominant. Click OK. I'm going to define the main beam, entering some point coordinate. So I call it concrete beam. And here I can just enter my point or coordinate, let's say. My beam is 5 meters long and 50 centimeters height. And you immediately see on my screen, and so you see live what you are entering here. I can zoom in and see my beam. Next step, I'm going to define 2 support plates. Same way, using the add sheet option. One is called support plate 1, which is 20 by 10 centimeters. Make sure that you don't make any typo. Of course, you can also click directly if you know exactly the position of your node. That's really up to you. You have the choice to click or to enter directly the coordinate of your points. You can also, if you have an Excel sheet with a list of points, copy and paste directly to this dialog box. Here is my support plate. I need to create another one on the other side. if you look on the left side, you have the model tree. You can expand it and see already the geometry part that have been created. So here we have the concrete beam and the support plate. I'm just going to duplicate this one. And automatically the program duplicate and give it the name support plate 2. And I'm going to move it to the other side. So I right click on support plate and choose the move shape option. So the support plate is automatically selected, and I'm going to move it 4.8 meter, and you immediately see the end position and click OK. So this is very intuitive. So now I have my concrete beam, my 2 supported plate. I'm going to create the loading plate. Again, I use the sheet entry. I call it loading plate 1, and I enter my coordinate. Again, this one are 20 by 10 centimeter. Since you immediately see what you are typing on the screen, you can also notice if you are making errors. It can be very convenient. So this is my first loading plate. I need to create one over there. So again, as you can see, this appears in the list of shapes. I'm going to duplicate this one, and I'm going to move it. So as you can see, you have a lot of options when you right click on the entity, so all the options that are allowed are listed there. Here we are. So my geometry is almost complete. I have my beam, my 2 supported plate, and the 2 loading plate. At any stage you can hide part of your geometry just by checking out. Now I'm going to define a load and the boundary condition of my model. Let's start with the load. So from the geometry menu, you can go to analysis. Here you have a lot of possibility, and one of them is attach load. You choose this one, and I give it a name. I call it force load. You can define a load case name, or just choose the default one. Here you can choose the type of target. I go for point. My type of load would be force, but you can see that it can be moment, prescribed deformation, acceleration, axisymmetric reinforcements in bar brace stress. So I choose for force, and then I'm going to select my 2 points where I want to apply my force. So they appear here. I'm going to apply a force of minus 1000 Newton, and I choose the direction of this force, which will be y, since my model is defined in the XY plane. Here you see the 2 arrows, which depicted the load. And now, if I go back to the model tree on the left side, and I expand the load tree under cases, I can see my geometry load set, and I can hide it or just show it by clicking on it. Now I'm going to add some supports to this model. So geometry, analysis, attach support. First one will be called BC1 for the left support. Again, you can define the support set name or just choose the default one. I keep the default one. I choose for point. I select my point here, and I constrain the X and Y direction. Here the support appear. I'm going to support the right side only in the Y direction. So same way, I go to analysis menu, attach support, call it BC2, keep the same support set name, define points, select the point, and I click on T2, and here are my support. So if you expand the support menu on the left side, you see a geometry support set 1, which contains your two boundary conditions, BC1 and BC2. And you can check in, check out, and basically you can hide or show the support. It's very intuitive. So we have a geometry, we have a load, we have support. We are now going to create a line which will be our reinforcement bar. So to create a line, I click on the add line icon, I call it bar, and I enter my two coordinate, which are 0, 0.05, 0, and the other one is 5, 0, 5, 0. So basically my bar is 5 centimeters below the bottom of my beam. If I go back to the geometry, now I can see my bar here. So our geometry is complete. We have the concrete beam, we have the loading plate, we have the support, we have the line for the reinforcement bar. Now we are going to define some and attach some property to this model. What's important to know, and which is quite different from previous version of Diana, all the things are done at geometry level. So property assignment, material and physical property are done at the geometry level, and that's what we are going to do now. And this is valid for the whole model, for reinforcement, and for interface. So I start with my reinforcement, and I click on the blue icon here, which is reinforcement property assignment. I select my bar. I can select it from screen or just right click on it from the geometry menu and click select. I'm going to define the material for this one. So I call it reinforce bar. I choose from the class reinforcement. I keep it linear elastic. And I just enter a Young modulus 2.1. I can define the geometry. So bar reinforce. The type is embedded, and for which I define the cross section. I don't need to specify any data by default, but if later on you want to change the integration scheme, you can define a data input. And then I click OK, and you see that the shape bar has disappeared, and now it turned to be a reinforcement. So my reinforcement is created. It's very intuitive in Diana 10. It's very straightforward. There's no further step needed. Now I'm going to assign some property to my concrete beam, clicking on the property assignment icon. So as you can see on top, we have three icons, one red, one blue, and one yellow. Yellow is for the general model, red is for the interface, and blue for the reinforcement. So I'm going to select the concrete beam just by clicking on it. Now I need to choose an element class. I go for regular plane stress, sorry. I'm going to define the material. I call it concrete beam. Class, I will choose concrete design code, and today I'm going to use our new material model, which is a GCSS probabilistic model code, which has been implemented in Diana 10. Internally, it uses a total strain rotating crack model with a linear curve in tension and a constant curve in compression. And in addition, I will also activate the random fill method. For more detail about this material model, I invite you to refer to our online material element manual, where this model is fully described. And you can also find a short description in our release notes, since this is just available in Diana 10. So I check the random fill option. So everything is already predefined. I'm going to change a few options, choosing for the C35 grade, for instance. And I'm going to change some parameter for the random fill option. Number of steps, I'm going to choose 5. And the decomposition method, I'm going to go for Fenton. And that's about it. For the geometry, I'm going to define a thickness of 0.1, 10 centimeter. And again, I don't define any data property, since I'm just going to use the default integration scheme. So we have assigned property to our beam, to our reinforcement. Now I'm going to assign a property to the loading plate and the support plate. So again, I click the shape assignment icon, I select the 2 loading plate, the 2 support plate. The element class is the same. I choose for plane stress. I'm going to define steel material. So I choose from the class steel. I keep it linear and just define the Young modulus and the operation ratio. For the geometry, I call it thick, for instance, and again I put 0.1, and that's it. Now I'm going to show you how to introduce interface. I'm going to place interface between our loading plate and the beam. This again is relatively easy. So now I'm going to click on the red icon, the interface property assignment, and I choose for edge, and I'm going to select the 2 edges which are connecting the loading plate to the beam. Now you can choose between 3 types of interface: connected, boundary, and no connection. Connected means that the interface will be created between two faces. Boundary means that the interface would be created between an edge and the outside world, so supported. And no connection means basically no connection. So in that case, we choose for the connected one. So the interface will be placed between the loading plate and the beam. I choose for structural line interface, and I'm going to define some property. Interface material. So the class is interface elements, and I'm going to choose for linear elasticity. The type is 2D line interface. So I put something stiff for the normal stiffness, and a bit weaker for the shear one. For the geometry, I again choose 10 centimeter, and I click OK. So we have assigned material and physical property to our loading plate, supporting plate, concrete beam, reinforcement, and interface. So all the property assignment is done. We now need to set up or define an element size or mesh seeding for this model. So you can do that by clicking on the set mesh property of a shape. And basically you can select the whole model, and you can choose between division or element size. I'm going to use element size, and I'm going to specify an element size of 0.25 meter. Here eventually you can choose for tetra or hexa dominant, but we already did in introduction, but you can also do that at this level. And I click OK. And now I'm going to create my mesh by clicking the generate mesh icon. So my mesh is created. Now I'm going to switch from the model tab to the mesh tab, and you can see some information about our mesh. So you can see the different mesh sets that have been created. the concrete beam, the support plate 1, support plate 2, loading plate 2, the interface, loading plate 1, and the other interface. Again, you can check off part of your model or check in. And here is our reinforcement. And you can just right click and access the context menu where you can say show only, hide. You can create new group of elements, so many options are available. So now that we have a model, a mesh, we are going to set up our analysis. From the analysis dialog box, which is on the right side. Of course, at any stage, if you want to change something or put the analysis window there, it's also possible. You have full flexibility. Just need to put it back now. Okay. So I'm going to start a new analysis by clicking the Add Analysis icon. So this is my first analysis. Right click. This is not so different with Dyna 9.6. In Dyna 9.6, you could already do the analysis setup that way. So for people who are familiar with 9.6, it's not a big step. So here I choose to perform a structural nonlinear analysis, for which I'm going to specify some steps. So this is my load set. I'm going to specify steps of size 4, for instance. Let's make it 70 of them. I'm going to activate the arc length control. For the equilibrium iteration, I just 10 iteration. And to make sure that I can run this analysis without too many problems, I just switch on the continue option for the convergence criteria. This is just to make sure that the analysis doesn't stop because it doesn't converge. The purpose of this demo today is just to highlight the workflow. So I'm going to specify also some output. So the device by default is Dyna native, Dyna interactive environment, Dyna IE, our new GUI, but you still have the possibility to choose from tabulated FEMView and FX+, but default is now Dyna native. I'm going to choose for displacement. What else can I add? Displacement, stress. I'm going to choose also some strain crack output. I can put also the crack width and some parameter output. So compression stress and intensity R. So I select a couple of output, load it. I can eventually save my command file just by save command, and then it comes to my working directory. I save it. So now I've defined my model, I have set up my analysis, and I'm going to run this analysis. I'm going to run it live because it takes about 2-3 minutes. It's not that that big, so at least it's a real case from A to Z. In the same time, if you have any question, feel free to place them in the question pane, and I will try to answer them. As you can see, at the bottom you have the message box, which gives you some indication about your calculation in terms of convergence. And also, if something wrong happened, then an error message would be raised in this dialog box. Another thing that I will highlight is that all the things you do in this new graphical user interface are scripted in Python. So all the modeling part, also analysis setup, and also the post-processing end up in a kind of text file where all the commands that you have been doing are scripted. So it means that you can replay this Python script at any stage, which might be very convenient if you want to rebuild your model, just changing some parameter. And Python also offers the possibility of loops and programming, so it's quite a powerful tool. I will show you in a moment where to find the Python script from your model and how to run it. We are now at step 40, 30 steps to go. We are almost there. So in the meantime, I'm going to show you where to find the Python script. On your computer, under your user directory, when you install Diana, a folder called .diana.ie is created. And you can see on mine, there is a lot of Python script. And the last one, this one, is actually the current Python script that we are using. And if I edit it, you can see all the Python commands that I have been using. Our analysis is almost finished. 15 steps to go. Later this year, we will probably cover the Python capability of Diana in a webinar. So keep an eye on our website because this will be advertised in the coming months. I got a question regarding where is the Python command box command. At the moment, the Python command box is hidden in my GUI, but once the analysis is finished, I will show you where to find it. So to answer the question about the Python command, if you go to Window pane, you can activate the command console, and then it appears, and you see all the commands that are scripted and saved in the Python file are also listed there. So every time I click on something in the GUI, the Python command appears over there. So for clarity, I'm going to close it again. So our analysis is finished. Now we want to look at some results. So the nice things with Diana 10 is we don't have to switch from one graphical interface to another one because everything is done in one environment. So I can just go to the results here. My results are automatically loaded. You can see the different load steps. And here's the output. I'm going to expand that. Use this. Here are my displacement, my stresses, my reinforcement results. I can present the displacement. If you right click, you expand it. I'm going to present the total displacement, for instance. You can present contour, you can show vectors. You can also tabulate results. So you can select part of your model, some of the load cases or all of them, and tabulate the results. And these results can be copy and paste to Excel, from where you can present graph or diagrams. This is very, very user-friendly. So I can just go through the different steps of my model just by clicking the arrow. So you can see from the legenda that it's changing. I can also change the units. You have the units dialog box on the right bottom corner. I can put things in millimeter. So we can see that the maximum displacement is changing when I go through the different steps. I can also present some crack strain. And we can also continue going through the steps to see the crack propagating. If you want, you can play with the settings. You have some options here that you can see from the property window. So here, there are a lot of parameters you can adjust. The number of scale level, anything you can imagine can be set from the property box. You can present some crack width, for instance. If I hide part of my model, go to mesh and I hide the concrete, and I only keep the reinforcement bar, I can show some results, the stresses in my reinforcement bar, for instance. So the output are pretty complete. You can, as I said, present contour, vectors, tabulate your results, show or hide part of your model. And the good thing is you can create your model, set up your analysis, and present the results in one environment, which is really a key point. And as I mentioned, all the things you are doing are scripted in a Python script. So at any stage you can replay this file, and it can also be seen as an exchange file. If you make a project for a client, you don't need to exchange big or heavy files. This text file is enough because you can replay it at any stage. So this is about the presentation of Dyna 10 for this particular case. I hope it gave you a good impression about the workflow. We try to make it easier and user-friendly, and we continue our development that way. So if you have any questions, please feel free to raise them in the question pane. I will try to answer them. Or if you want to raise your question later, you can drop an email to info@tnodyna.com. I'd like to thank you for attending this webinar. And please keep an eye on our website because, as you probably know, there are webinars on a regular basis. So we keep you posted, and just keep an eye on our website. Thank you very much.